Hello, let us start for the discussion of the mass correction in Rydberg constant from Bohr's theory. As we have seen in lecture number 1 and lecture number 2, the calculation of EI difference EF, and it was h nu, and from that we have calculated 1 by lambda, that is wave number, and that is equal to r infinity z square 1 by ni square difference 1 by nf square. Now here we have written r infinity. In that sense it has specific meaning. What is the meaning? Let us try to understand. In Bohr's theory, the nuclear mass was taken as infinite with respect to the electron. And when the nuclear mass is infinite, then the center of mass is located at the center of the nucleus, and the distance between the center of the nucleus and the electron was taken as r, where r is the radius of the orbit through which the electron revolves. Now the question arises, when we shall consider masses of different atoms excluding hydrogen 1. For example, the query arises from the spectral analysis, because the analysis was not supporting the Bohr's theory. The analysis was coming from the spectral nature of deuterium and the tritium. The deuterium has 1 neutron at the nucleus, and tritium has 2 neutrons in its nucleus. So this mass change with respect to the hydrogen, which has single proton in the nucleus, was not reflected in this calculation. For that reason, the calculation was changed and the finite mass correction of nucleus was taken into account. If we consider the figure like that instead of the first figure, that here two masses or two spheres we have drawn, where capital M is the mass of the bigger one, which is taken as the nucleus, and small m is the mass of the smaller one, which is taken as electron mass. If so, then instead of the location of the center of mass at the center of the nucleus, the center of mass must lie in between the two centers of the two finite masses. And from the figure you are seeing that if the distance of the center of mass from the center of the nucleus is r1 and the distance of the center of mass from the center of the electron is r2, then r1 plus r2 should be r as we have taken earlier. So r1 plus r2 is small r, it is the equation number 1, and from the moment calculation, capital M into r1 equal to small m into r2, where we can write that we can replace r2 by r1. What we have done here, we have replaced r2 by r1 and r1 by r2. Then finally, when we have replaced r1 by r2, then finally we have changed it in terms of r. That is, just check initially this relation, then r2 gets changed to r by 1 plus small m by capital M. Similarly, r1 gets changed to the value r by 1 plus capital M by small m. When the center of mass is taken at that point, with respect to this point, the two body system will revolve, and if the two bodies they revolve along the anticlockwise direction or along the clockwise direction, then and if they have the angular velocity as omega, then the total angular momentum of the system is capital M r1 square omega plus small m r2 square omega. Now replacing the two factors of r1 and r2, finally we get the total angular momentum of the system is capital M into small m by small m plus capital M into r square omega. Here this factor small m capital M by small m plus capital M is termed as small mu, that is the reduced mass. Rydberg constant for the condition of the finite nuclear mass is represented by mu e to the power 4 by 8 epsilon square Ch cube instead of m e to the power 4 8 epsilon square Ch cube. So you must understand now that why we have written R infinity when the mass of the nucleus is infinite. If we take the ratio of Rm and R infinity, then it gives the value as 1 by 1 plus small m by capital M. As capital M increases, small m by capital M decreases. So Rm increases. If I plot a graph, capital M along x-axis, Rm along y-axis, then we get the graph like this. So initially it will increase, then it will be a steady condition. So that steady condition, when gets extrapolated backwards, it gives R infinity. So this is the full consideration or the calculation regarding the finite nuclear mass of Bohr's theory. If you have any query, put your questions, or you can interact in the next session through questionnaire in the corresponding boxes. So have a good day. Goodbye.